Let us commence this narrative with a moment of profound stillness. Imagine yourself positioned in the midst of a vast field on a moonless night, where a gentle chill caresses your skin, and no artificial light disrupts the purity of the darkness. Raise your gaze to the deep black canopy above, adorned with thousands of twinkling points of light. Each diminutive spark, though seemingly insignificant amid the overwhelming expanse, serves as a beacon of eternity. The light reaching your eyes at this instant may have departed its parent star hundreds, thousands, or even millions of years prior. You are receiving an ancient message, an embrace from a distant past. Amid this immensity and chill, a question arises not solely for astronomers, who pursue cosmic mysteries through enormous telescopes, but for anyone who has ever felt diminutive and isolated in this world. It is the inquiry of whether, somewhere far beyond, an individual identical to you stands beneath the night sky of an alien planet, also gazing upward and pondering the very same question. This is not a fanciful scenario from science fiction films, nor a romantic consolation employed by poets to soothe human sorrows. It represents one of the most serious, groundbreaking, and challenging hypotheses in modern physics, constructed upon foundations of statistical probability and the mathematical structure of the cosmos. The notion that events on Earth, from the initial emergence of bacteria fostering life in primordial waters to your first awkward kiss under dim streetlights, might be occurring or have occurred identically elsewhere in the infinite universe, is a concept both terrifying in its erosion of our uniqueness and captivating in its promise of profound cosmic connection. Let us delve deeper into this account, starting from the smallest building blocks that form our reality, elements that appear random yet adhere to unyielding mathematical laws. To comprehend why our history might repeat, we must examine the fundamental nature of matter and space. Envision the universe not as an empty void but as an enormous, boundless, and continuously expanding chessboard. On this board, the pieces are not kings, queens, bishops, or knights, but the basic particles constituting everything: protons carrying positive charge, neutrons neutral in charge, and tiny electrons bearing negative charge. All that we perceive, from the table at which you sit, the breath you inhale, to distant stars, arises from the marvelous and intricate combinations of these fundamental particles. The issue resides in the quantity of arrangement possibilities. Although the number of ways to combine these basic particles to form a blazing star, a verdant planet like Earth, or a complex brain capable of self-awareness like the human mind, is unimaginably large, physicists assert a crucial point: this number is not infinite. It possesses a definite limit, constrained by fundamental physical laws. The distinguished physicist Max Tegmark, a pioneer in multiverse research, has presented a mind-numbing calculation regarding the limit of feasible matter configurations within a given spatial volume. He proposes that in a space equal to the volume of our observable universe, a figure already astounding, the number of possible matter configurations is 10 to the power of 10 to the power of 115. Take a deep breath and attempt to fathom this number. It is a figure that, if written out, would fill our entire observable universe with zeros. Yet, no matter how immense this number, if our universe, or more precisely the entirety of space permitted by theory, is spatially infinite, without boundaries, mathematics compels us to confront an inescapable truth: patterns must repeat. Consider a simpler analogy. Suppose you possess an old typewriter, and you begin striking keys entirely at random, without cessation, forever. You type, producing a random string of characters. You continue, generating another string. With infinite time and infinite space for the machine to operate, inevitably at some point, you will inadvertently type the complete classic literary work Tale of Kyo by Nguyen Du, with every punctuation mark and word precisely accurate. Then you will reproduce the intricate plays of Shakespeare, the latest scientific articles, and even the entire history of humanity recorded on paper. The universe operates on a similar principle, but at the scale of physics and atoms. The fundamental particles of matter, protons, neutrons, and electrons, are the keys, and infinite time coupled with infinite space is the most patient typist. Based on this cold yet compelling statistical probability, scientists have conducted inferential calculations about the distance to your nearest duplicate. This duplicate is not merely someone with a face resembling yours, but a perfect replica, with identical genetic structure, the same memories stored in every brain fold, from your formation as a fetus to this very moment as you absorb this information. The estimated distance to your nearest duplicate, according to these calculations, is 10 to the power of 10 to the power of 28 meters. For perspective, this number vastly exceeds the size of the observable universe, the portion where light has had time to reach us. Furthermore, scientists calculate that a replica of our entire observable universe, including our beloved planet Earth, the radiant Sun, the entire Milky Way with hundreds of billions of stars, and the complete history of humanity, might exist at a distance of 10 to the power of 10 to the power of 118 meters. What does this signify for our perception of reality? It implies that somewhere, beyond the reach of humanity's most powerful space telescopes, another Earth orbits a star similar to the Sun. In that version, history might have diverged entirely. Perhaps the colossal dinosaurs, creatures that dominated the planet for hundreds of millions of years, were never eradicated by the fateful impact of the Chicxulub asteroid 66 million years ago. They continue to evolve, possibly developing a distinct form of intelligence, a mighty reptilian civilization, and humans, our modern species, remain forever an unrealized possibility in that universe's temporal flow. Alternatively, everything might unfold identically to here, every historical detail, every bloody war, every peace treaty signed, every world-altering scientific invention, occurring precisely as such. The sole difference, a minuscule detail, might lie in a decision you made this morning. In that version, your duplicate chose to wear a blue shirt instead of the white one you are wearing. However, the concept of repetition somewhere extends beyond a flat, infinite universe where fundamental physics mirrors ours. Modern physical theories, particularly in cosmology, open doors to a far grander and stranger notion, the multiverse, where reality is far more complex and diverse than what we can observe with naked eyes or current instruments. Begin with the theory of eternal inflation. Leading cosmologists today posit that immediately following the Big Bang, the moment when our entire universe is believed to have formed from an infinitesimally small and scorching singular point, the universe underwent a phase of expansion at a terrifying speed, faster than light. Imagine this expansion not as objects moving through space, but space itself stretching like a tablecloth yanked forcefully. This process can be likened to a loaf of bread rising in an oven. Crucially, this inflationary process does not halt simultaneously everywhere. It ceases in local regions, creating separate bubble universes drifting in an eternal inflationary sea, perpetually expanding. Our universe, with all its brilliant spiral galaxies, colorful nebulae, and beloved planet Earth, is merely one among countless such bubbles, floating in an unending inflationary ocean. In this infinite ocean of bubble universes, every feasible physical scenario must occur at least once. There will be bubble universes where fundamental physical constants, the immutable rules governing all interactions, match ours exactly. There, the speed of light remains the ultimate velocity limit, gravity anchors us to the ground with the same intensity, and chemical elements bond in the identical manner. In those universes, the evolutionary history of stars and planets might proceed just as we have observed and learned. But there will also be entirely divergent bubble universes. Some where gravity is so strong that stars never form, or so weak that planets cannot retain atmospheres. Others where Earth forms without a moon to generate tides, utterly altering biological evolution. Or, in another scenario, the mighty Roman Empire never collapses, and human history veers in a completely different direction, without the Middle Ages as we know it. Not stopping at variations in physical constants, string theory, one of the most promising candidates for a theory of everything to unify all natural forces, proposes even greater structural diversity in space. This theory predicts at least 10 spatial dimensions, rather than the 3 spatial and 1 temporal dimension we perceive. The extra 6 or 7 spatial dimensions are believed to be tightly curled at an exceedingly small scale, imperceptible to us directly. The manner in which these dimensions curl, known as Calabi-Yau geometry, determines the fundamental physical laws we observe. Although the number of curling ways might be enormous, around 10 to the power of 500 different methods, if the number of universes in the multiverse is infinite, as eternal inflation implies, then the repetition of physical structures, and thus of Earth-like planets, becomes inevitable. The physical structure forming our cherished home, with laws we have spent centuries discovering, is not unique. Perhaps the most intimate yet simultaneously perplexing and perception-challenging aspect is the many worlds interpretation of quantum mechanics. This describes reality at the microscopic level, where fundamental particles lack definite states until measured or observed. Prior to measurement, they exist in a superposition of all possibilities. The many worlds interpretation, proposed by physicist Hugh Everett in 1957, offers a bold explanation. Rather than this superposition collapsing into a single outcome upon observation, all possibilities become real, but each in a separate branching universe, detached from the one we experience. Imagine that every time you face a decision, even trivial like turning left or right at an intersection, the universe splits into two branches. In this branch, you turn left and might encounter your destined life partner in a small roadside cafe. In the other branch, you turn right and miss that meeting, steering your life in an entirely different direction. Applying this to cosmic history, we can reimagine pivotal events. Return to the Chicxulub asteroid hurtling toward Earth 66 million years ago. In conventional understanding, it was a singular event extinguishing dinosaurs. But under the many worlds interpretation, there might be a branch where the asteroid's trajectory deviates by a few degrees, grazing Earth's thick atmosphere, dissipating most energy, and soaring into endless space. In that branch, colossal reptiles are not annihilated. They persist in evolving, potentially into intelligent beings constructing their own civilization, with stone cities and unimaginable inventions, while we humans, small primates, remain forever an unrealized biological potential, left behind in evolution's process. Thus, what occurred, like the dinosaur extinction, actually transpires differently, as their continuation, in a parallel reality branch right now. To further bolster the belief that Earth is not a unique miracle and humanity's story is not a singular event in the cosmos, let us review scientific history and humanity's place in the larger cosmic picture. The Copernican principle taught us a valuable lesson in humility centuries ago: Earth is not the center of everything. That was a profound perceptual shift. Subsequently, we realized that the Sun, our radiant energy source and solar system center, is merely an ordinary star, even somewhat small, compared to hundreds of billions of other stars in our Milky Way galaxy. And the Milky Way, our beautiful spiral galaxy we call home, is just one among hundreds of billions of galaxies in the observable universe. Our planetary system, with its diversity of chemical elements forming everything, is composed of the universe's most common elements like hydrogen, helium, carbon, and oxygen. Heavier elements, such as iron or gold, are forged in the depths of massive stars, cosmic forges, and scattered throughout space. If the basic components forming us, the atoms, are common, and the foundational physical laws creating life, like gravity, electromagnetism, and nuclear forces, are universal, applying everywhere in the observable universe, why would the ultimate result of that combination, complex life, civilization, and humanity's rich cultural history, be unique? To assume Earth is the sole place where all these conditions converge to create a reality identical to ours is scientific arrogance, a grave violation of statistical probability rules when facing near-infinite space and time. Recently, space missions like the Kepler telescope and especially the James Webb Space Telescope have transformed the field, detecting thousands of exoplanets in our Milky Way. Among them, many reside in habitable zones around their host stars, with sizes comparable to Earth, and some show signs of atmospheres and liquid water. This further strengthens the conviction that basic conditions for life are not rare. In the year 2025, the James Webb Space Telescope has continued to yield groundbreaking discoveries, including new evidence for a planet orbiting the closest solar twin to our Sun, a finding announced in August that enhances our understanding of potential habitable worlds nearby. Additionally, astronomers have unveiled details of a cold and chaotic exoplanet with unexpected atmospheric compositions, revealing fainter infrared signatures than anticipated, which suggests complex chemical processes at play. The telescope has also captured a stunning three-dimensional view of a scorching exoplanet's atmosphere, specifically WASP-18b, a massive world where temperatures and dynamics challenge existing models. Furthermore, tentative evidence of life on the distant planet K2-18b has emerged, with scientists detecting potential biosignatures in its atmosphere, sparking debates about extraterrestrial habitability. These revelations, combined with the discovery of rapidly feeding supermassive black holes in the infant universe, underscore the dynamic and diverse nature of cosmic environments, making the case for repeated life-bearing conditions even stronger. Nevertheless, this narrative of repetition immediately prompts a major concern, a famous paradox that has puzzled thinkers for decades, the Fermi paradox. If complex life and technological civilizations capable of self-sustenance or development repeat as frequently as suggested, with near certainty in an infinite universe, why does the sky remain silent? Why have we received no radio signals, observed no artificial megastructures, and found no clear evidence of intelligent extraterrestrial existence? Perhaps the answer to this eerie silence lies in a concept both tragic and profoundly cautionary, known as the Great Filter. This hypothesis posits that, in the evolutionary journey from inanimate matter to a civilization capable of interstellar travel and communication, there exists an extraordinarily difficult barrier to surmount, such that most life forms are eliminated before reaching that stage. Where might this Great Filter reside? Two possibilities evoke shivers. The first possibility, the Great Filter, lies in our past. For instance, the formation of life from inorganic matter, abiogenesis, or the development of eukaryotic cells, or the emergence of multicellular conscious life, might be probability leaps of extreme rarity, which Earth fortunately overcame. If true, the universe might abound with Earth-like planets, but most harbor only bacteria or single-celled organisms. We are rare fortunate survivors of the toughest hurdle. The second possibility, and the one causing greatest anxiety, the Great Filter, lies in our future. This means advancing to technology sufficient for space colonization or strong communication signals is the point where all civilizations fail. Technological civilizations tend to self-destruct through their own breakthroughs. It could be global nuclear war, uncontrolled artificial intelligence explosion, irreversible climate change, ecosystem collapse, or uncontrollable advanced biotechnology. If true, the universe's silence warns that any civilization reaching our technological level soon ends itself. In 2025, discussions on the Fermi paradox and Great Filter have evolved with new perspectives. Some theorists propose that the paradox resolves not through a single catastrophic filter but a series of probabilistic hurdles, each reducing the likelihood of civilizations becoming detectable. Artificial intelligence has been highlighted as a potential Great Filter, with studies suggesting that advanced AI could lead to self-destruction or containment, explaining the lack of observable extraterrestrial signals. Physicist Brian Cox has elaborated on this, emphasizing how the Great Filter might represent a universal challenge for intelligent life, aligning with ongoing debates about humanity's own technological risks. Additionally, resolutions incorporating statistical models indicate that we may have passed early filters, but future ones loom, urging caution in our development. This leads to a spine-chilling reflection: the catastrophes humanity faces, past mass extinctions, current ecological imbalances, nuclear war risks, or unchecked advanced technology growth, may not be Earth's isolated tragedies but a universal law, a mandatory script in technological evolution across the cosmos. Somewhere distant, another sibling civilization grapples with a catastrophic climate crisis or debates deploying a new mass destruction weapon. Their scientists also gaze at the night sky, sharing the same loneliness and self-questioning: are we alone? Our arduous survival struggle is not an isolated drama but a universal play, a recurring test every intelligent life in the universe must face. Yet, let this story conclude on a note of hope and acceptance rather than paralyzing fear. The statement that what has happened on Earth might also be happening somewhere is not merely a dry physical proposition based on probability, it is a profound philosophy about connection and existence's meaning. Scientifically, we cannot deny mathematical truth. With space and time's immense infinity, or even in an infinite multiverse, the probability that Earth, with its specific evolutionary history and our specific humanity, is a unique entity approaches zero. Repetition is an inevitable consequence of infinity. Physical laws, like the most diligent and loyal builders, given sufficient materials, the basic particles, and sufficient time, will construct similar structures, creating similar scenarios. Recent advancements in multiverse theory as of 2025 further support this. A study has cast doubt on the universe's accelerating expansion, suggesting dark energy might weaken over time, which could imply evolving cosmic structures conducive to repeated patterns. Theories on dark matter origins point to a mirror world and the universe's edge, proposing natural emergences that allow for diverse yet repeating realities. Google's Willow quantum chip has sparked debates on multiverse implications, demonstrating computations aligning with many worlds' principles. Additionally, scientists have proposed a particle linking to a fifth dimension to explain dark matter, expanding possibilities for multidimensional repetitions. In Eternal Inflation updates, new models challenge the Big Bang narrative, suggesting gravitational waves shape the universe and that eternal inflation persists in some regions, creating endless bubble universes where repetitions are assured. Emotionally, this idea provides strange and warm consolation, though initially seeming to diminish our importance. It offers hope that humanity's historical terrible mistakes, war crimes, inhumane acts, might have been corrected and avoided in another parallel world. That great lost artworks from wars, ancient libraries holding millennia of knowledge burned to ash, might remain intact and cherished by another humanity version in a distant Earth replica. Even if reason dictates we may never contact these cosmic siblings, perhaps due to insurmountable spatial distances exceeding our travel capabilities, or barriers between spatial dimensions or bubble universes being impassable, knowing we are not a random error, a solitary accident, or a unique meaningless creation event, helps humanity feel less alone in the universe's eternal dark night. Earth's story, with all its bursting joys in discovery, heart-wrenching pains in loss, ceaseless struggles to rise and seek meaning, may not be a solo performance. It could be a song sung repeatedly, an eternal and indestructible chorus of existence, echoing through countless parallel realities. And who knows, right now, as you finish reading these lines, your duplicate somewhere, under a slightly different night sky, has just done the same. Perhaps they smile at their night sky, feeling an invisible connection, a gentle echo across billions of light years, a confirmation that, wherever we are, we all gaze upward together and wonder together. We are not alone in this vast loneliness.